All right, this is where things get a little messier. And the quotient rule in the video after this one gets even messier. So here it goes. So the product rule. This states that if I'm taking the derivative of two functions multiplied by each other, it's not as nice as we'd like it to be. What I'd like, right? I'd like it to be like the other rules. Just add the derivatives together, subtract the derivatives together, multiply the derivatives. But it's not. It's not, right? You can't just take the derivative. There's a couple examples that we could go through to show why this doesn't work, or you could check it yourself with some actual functions. What it actually equals is the derivative of the first function times the original second function plus the original function times the derivative of the second function. All right, so actually it's two parts, and each part gets one of the derivatives, like the derivative on one of the parts. Doesn't matter what order you write these in. All right, so that's the product rule, and we can show a little bit about where it comes from. The proof of this one is a little messier, but it's nothing super crazy, but we're not going to go through it. Example 4. For j of x equals some function f times some other function g, part A, I want you to find j prime of 2 if f of 2 equals 3, f prime of 2 equals -4, g of 2 equals 1, and g prime of 2 equals 6. So notice that we're going to need all of this information about both individual functions and their derivatives at this point. So j prime of 2, well, first off, let's look at j prime of x. Let's look at this derivative at any place. Well, the product rule tells us that the derivative of j is going to be f prime of x times g of x plus f of x times g prime of x. We're just using the product rule. J is just the product of two other functions. So specifically what we want is we want j prime of 2. So evaluate this function at 2. That'll be f prime of 2 times g of 2 plus f of 2 times g prime of 2. Let's substitute everything in, and we'll get our answer. We'll do that on the next page. F of 2 times g prime, 3 times 6. What's next? F of 2 times g prime. Wait a minute. I already did f of 2 times g prime. Oh, we did it in the other order. We did this term first. The other one's going to be f prime times g. So -4 times 1. There we go. F prime times g plus f times g prime. That'll be -4 plus 18 or positive 14. So even if we don't know what the functions are, right? I don't know what f and g are. We can still use the product rule. Part B. Find j prime of x. What if f of x equals x squared plus 2 and g of x equals 3x cubed minus 5x? Well, again, j prime is going to be what we said before. We used the product rule, right? J prime of x is f prime times g plus f times g prime. So all we have to do is evaluate these derivatives. And these parentheses aren't necessary here. Parentheses are only necessary when you have like multiplication and other more complicated operations. But if you just have addition, we have this. We can use the power rule and a bunch of other rules to get that f prime is 2x and g prime is 9x squared minus 5. And hopefully at this point, you're comfortable enough with the power rule and the sum rule, the constant multiple rule, to see where these are coming from. But you can also go off to the side and do them in longer steps. Now we just replace everything. What is f prime of x? F prime of x is 2x times g. What is g? 3x cubed minus 5x. Now we need parentheses, right? Because f gets multiplied by the entirety of g. Plus, what is f of x? F of x is x squared plus 2 times g prime of x, which we said was 9x squared minus 5. And now is the annoying part. Now we have to simplify. So we got to distribute. It's going to give us 6x to the fourth minus 10x squared. And then we have to FOIL for the second one. That's going to give us 9x to the fourth minus 5x squared plus 18x squared minus 10. Collect like terms. 6x to the fourth plus 9x to the fourth. That's 15x to the fourth. And then minus 10x squared. Now we're at minus 15x squared. Now we're at 3x squared. And then the last thing is just a minus 10. This is the derivative. Now, of course, there's a way to do this without using the product rule at all, right? We could just find j of x if we wanted to. Like, there's another way of doing this problem, and we should get the same answer. J of x is f times g. So it's x squared plus 2 times 3x cubed minus 5x. We can just find what j of x is. It's 3x to the fifth minus 5x cubed plus 6x cubed minus 10x. So we should just be able to use the other differentiation rules to also get 15x to the fourth minus, oh, this combines to 1x cubed, which is going to be 3x squared, minus 10. So these should be the same. And indeed they are. So in this case, the product rule doesn't actually make things any easier. In this specific case, it doesn't. But this is a good example to kind of show you that, yes, the product rule is legitimate. It works. Whereas if you just multiplied the derivatives together, you'd get nothing close. You do have to use that whole long rule, f prime g plus fg prime. All right, and that's pretty much it for this video. And then we've got the quotient video with some little extra bonuses at the end.